Hello everyone, my name is Connor Fitzpatrick and I am an ECS engineering student in the Computer Integrated Manufacturing Honors Junior class headed by a Miss Rhonda Cosgrove. My research project has been decided that it will be the AGV, also known as the Automated Guided Vehicle. So the inventor of the AGV is Arthur Mack M. Barrett Jr. This man was born in Evanston, Illinois in 1921, where he later received his Bachelor of the Arts degree and lived for many years in Lake Forest. He did end up selling his business, which we will talk about later, to Nissan Industrial Equipment Corporation, now Nissan Forklift, on July 22nd, 1988. He went on to die at the age of 89 on Tuesday, August 17th, 2010. And the bottom right picture is a depiction of him. So a brief history of AGVs is that they were created in the Barrett Electronics Corporation in 1954 for industrial applications, invented by Arthur Barrett, also known as Mack. The term AGV, however, was only adopted in the 1980s. Previously, this type of technology was called driverless vehicles. AGVs were mainly used for only factories and industrial plants, moving products or materials from station to station or other such variables. So the first AGV was dubbed the Guidomatic for how it followed magnetic fields, which we call tracks, which it used as tracks in the factory. Barrett had placed copper wire through the floor of the facility, and this copper wire was emitting magnetic fields that the Guidomatic would follow and go place to place and be used as a track. So some types of AGV are known as the laser-guided AGVs. These specifically used mounted laser sensors to place a pointed laser on an object. That laser would then reflect off the object into the sensor, and then the computer interface would then measure the distance based on that reflection and orient itself to the object. The next type of AGV is known as a fixed path systems. These systems used materials like wire or tape to create a path for the AGV to follow. This technique, however, does not allow for easy manipulation of the route that the AGVs would use because of how difficult it was to manipulate the route. Up in the top right, you can see a specific example of a fixed path system because you can see the AGV here in the green and then the apparent path that it would be following. Another type of AGV is called the free-range systems. A free-range system guides the AGV using a computer-based program that communicates within the onboard microprocessor and controls the system. This programming translates into controlled and adjustable movements. So, for example, if you look at the diagram in the middle of your screen, you can see that there are specific communication nodes spread about the facility. You can see the AGV here in yellow. As you can probably determine that this is more of a fixed path system, but it does allow the free range aspect by adapting these signals into the computer's interface, and that computer interface then interprets those signals as the computer-based program would, and then decide its direction and course. The next type of AGV is called a camera-guided AGV. This used onboard cameras to see their surroundings while performing tasks. These AGVs are most helpful when you require precision navigation through a crowded area or an area short on space. So these specific AGVs were used to make tight turns just throughout the facility, and it was overall more a precise way of going throughout the facility. More types of the AGV include the optical guided AGV, which receives guidance from photosensitive tape that operators would place around the facility floors. This would help them know where they are on the track, and the optical guided AGV could measure distance between established stop location using wheel odometers. Another type is forked AGVs, and they are essentially forklifts that can pick up and move a wide variety of loads to different levels. Branching off of the specific forked is the unit load AGVs. They are also known as large chassis automated guided vehicle systems. These are used to transport heavier loads with the assistance of components like roller bins and lift lower mechanisms. The next type of AGV is the inertial guided AGV. This specific type relied on magnets mounted underneath the floor to get their sense of direction. They determined their location and where they need to move using, number one, a device to sense the magnets, number two, a gyroscope to measure the unit's heading, and number three, a wheel odometer to calculate how far the vehicle has moved. Another type is the automated guided carts. This specific AGV was used to transport hard-to-move loads, like, for example, aircraft parts. Another type of AGV is the towing vehicles. They are very, very simple AGVs that can transport heavy pallet loads, but they cannot assist in putting together small parts. So they are essentially like the forked AGVs and the unit load AGVs. The next type is called the outrigger AGVs. They are built with two horizontal legs known as outriggers. These specific outriggers provided stabilization and lateral support so that the AGVs can move racks, pallets, and just rolls. Some AGV components found in most AGVs can consist of traction motors for assisted moving, traction batteries that provide power, which are mostly lithium batteries, a computer interface that controls the main processor and gives the AGV instructions. So like in the previous slide where we had the diagram with all the signals, that computer interface got the input from those signals, sent it through the main processor, and then gave the AGV its instructions via the processor's output. And then a payload interface for material handling. If we look at the bottom right, we can see an example of an AGV by the brand of Optimatics. Here we can see that the AGV will have a safety scanner to be able to scan in front of it and make sure it's not going to do any potential damage. You also see that it has an emergency stop feature as a button so that the human operators can stop the AGV in its tracks before it does cause damage if the scanner does fail. You can see that it also has a safety color, which is obviously the yellow, the bright yellow, which is easily visible. It also has reflecting foil so that lights or anything that can detect light can bounce right off this foil and then obviously divert its path to make accordance with this AGV. It also has a safety bumper or scanner. Basically, when it runs into something, it'll say, hey, there's a thing in front of me, to the side of me, wherever it is I have hit something, I need to adjust my path and divert it. It will also have flashing lights. This is just in their safety concerns so that you can clearly tell it, see it in the facility. It has speed adjustments, so if it's going too fast, too slow, whatever the facility may need, it can adjust it. And then a sound signal, so that if it is about to cause harm, you will be able to hear it and potentially avoid it. Some benefits of using automated guided vehicles are reducing human error in operation. They increase efficiency. They don't require much maintenance. The only maintenance really required for an AGV is setting up the pathing and then changing the pathing based on the needs and necessities of the facility and or the corporation/company that is in charge of the AGV. And then ultimately it saves money for the company based on labor costs. While the initial price of the AGV systems is pretty hefty, in the long run, you're not going to have to pay robots a salary. Whereas if you had human operators, you would. So in the long run, having AGVs will save you money over having to pay humans. So we are now to modern AGVs. This is a look at modern and upcoming future AGV technology. So industries are currently in the midst of a transformation through the use of AGVs, and they are calling this transformation Industry 4.0. However, this comes with some disadvantages like big data. Big data is essentially the idea of too much data being inputted, and to the where the computer interface cannot handle that amount of data. Though companies are combating this through the use of efficiency and the additional profits through less labor costs, as mentioned on the prior slide. So if you look at the top right AGV, that is the AGV of the future, the platform in which the car is sitting on. It moves cars around as essentially a unit load. Whereas the bottom right is a more modern AGV you would find in a warehouse or a facility. So in conclusion, AGVs are becoming integrated in more and more companies, whether they be retail stores in the back of said stores or factories, facilities, warehouses, you name it. AGVs help the manufacturing process and move materials or products from station to station. For more information on this topic, I recommend you go visit this link where the automated guided vehicle company has made a 1 minute or so long video. It's just a generic overview of AGVs, and I really recommend you check it out if you have any questions. So this is a list of the current links and sources of all of my research and pictures. And thank you for paying attention to my slide, and I hope you enjoy the rest of your presentations. Thank you.